Yeah, good afternoon students. In the previous class we discussed about different types of colloids and different types of different types of dispersions, and we stopped at different types of colloidal systems. That colloidal systems there are three types. Those are lyophobic colloids, lyophilic colloids, lyophobic colloids and association colloids. Here lyophilic colloids include, lyophilic means philic indicates loving, lyo indicates solvent. The colloids which are having the property of solvent loving property, those colloids are called as lyophilic colloids, and in this when the dispersion medium is water, it is called as hydrophilic colloid. Means if you take the solvent as a water, then it is called as hydrophilic colloid. If the dispersion medium is an organic solvent, it is called as hydrophobic colloid. Next, lyophobic colloids. Here these lyophobic colloids, they are solvent hating in nature. Phobic means they are hated, solvent hated colloids. And third one is association colloids. The name itself indicates association of the molecules takes place to form a colloidal dispersion. We will see the each and every classification in detail. This is the in detailed classification of colloids. Based upon the interaction between dispersed phase and dispersion medium, the colloids are classified into lyophobic salts and lyophilic salts. Here sometimes we are mentioned the colloidal systems as salts. Other name for colloidal system is given as sol. Okay, so don't confuse about it. Sometimes it will be represented as sol also. Lyophobic salts or lyophobic colloids, lyophilic salts that or otherwise lyophilic colloids. And if the based upon the particles of dispersed phase, these colloids are classified into multimolecular colloids, macromolecular colloids, associated colloids. Here based upon the dispersed phase and dispersion medium, the type of this colloid will be different. Here if you see, dispersed phase is solid and dispersion medium is solid, then it is said to be a solid sol or solid colloid. And examples for this is some colored glasses and gemstones. And dispersed phase is solid and dispersion medium is liquid, then it is said to be a sol. Paints and cell fluids are called as examples. And dispersed phase is solid and dispersion medium is gas. Aerosol is the best example. Example is smoke and dust. And dispersed phase is liquid and dispersion medium is solid and it is said to be a gel. Cheese, butter and jellies will come under this classification. And if the dispersed phase is liquid and dispersion medium is liquid, it is said to be an emulsion. Examples are milk, hair creams. And if the dispersed phase is liquid and dispersion medium is gas, it is again the sol is given as aerosol. Fog, mist, cloud, insecticide sprays, all these will come under this type of aerosols. And dispersed phase is gas and dispersion medium is solid and it is said to be a solid sol. Example is pumice stone and foam rubber. Gas is a dispersed phase and dispersion medium is liquid, and for sol is called as foam. Froth, whipped cream and soap butter, soap leather will come under this classification. And based upon the dispersed phase and dispersion medium, different types of examples are also given here. You can go through that. And coming to the properties of lyophilic colloids and lyophobic colloids. Here I given the both lyophilic colloids and lyophobic colloids in the differentiation manner. By that way it is easy to understand. Okay, so just go through this. Lyophilic colloids. What are lyophilic colloids? And here the colloidal particles have greater affinity for the dispersion medium. As the name itself indicates, lyophilic colloids are, philic means solvent loving colloids. Here all the colloidal particles, whatever the colloidal particles we are having, these colloidal particles are having more affinity towards the dispersion medium what you have taken. Whether you have taken water or organic solvent, whatever it may be, the dispersed particles are having more affinity towards, means they are having more attraction towards dispersion medium. Whereas lyophobic colloids, these colloidal particles have very little affinity for the dispersion medium, means a very little, means they will attract slightly only. Sometimes they won't get any interaction with the dispersion medium. Here, whereas lyophilic colloids, owing to their affinity for the dispersion medium, the molecules disperse spontaneously to form a colloidal solution. Here, lyophobic colloids, materials does not disperse spontaneously, and hence lyophobic salts are prepared by dispersion or condensation method. Here this second point indicates how they are going to prepare. Here lyophilic colloids, it is easy to prepare the lyophilic colloid. Say for example, if you want to prepare a solution of a polymer, say for example HPMC, hydroxypropyl methyl cellulose is a polymer, which is if you want to prepare a colloidal dispersion with the HPMC, just take the small quantity of HPMC and dissolve it in either water or alcohol. Immediately it will dissolve, spontaneously it will form a solution of polymer, means it is a solution of the polymer only, but if you observe the properties, the polymeric solution will have colloidal property. But whereas if you take lyophobic colloids, it is not possible to disperse the lyophobic colloidal particles throughout the medium very easily. So for that purpose, because of that reason, these lyophobic colloids are prepared by either dispersion techniques or by condensation methods. And here lyophilic colloids, they will form reversible sol. Reversible sol means, here if you just now I given a example of preparation of hydroxypropyl methyl cellulose solution with the either alcohol or water. Just take the solution of the lyophilic colloid and just allow it for drying. If you allow it for drying, the sol will get dried. But again, if you want to get the reverted back, means if you want to get again a sol by adding simple solvent, what will happen immediately once it is dried? Also, if you added some amount of solvent, immediately the sol will get dissolved, means the dispersed particles will get dissolved in the solvent, and again it will form a colloidal dispersion, means it is whether it is subjected for drying process also, if you add a small quantity of solvent to the dried sol, you will get a dispersion. But whereas these lyophobic colloids, these are irreversible sols. Once the dispersed particles are separated out from the liquid medium, it is not possible to revert it back to the original position. Next, coming to the viscosity of the dispersion medium, here these lyophilic colloids, they will increase the viscosity of the preparation to a great extent. Means, say for example, just now I given HPMC, right? HPMC, if it is dissolved in water, and the resulting solution will be a viscous solution. Okay, means lyophilic colloids, they will give a great viscosity to the medium. Whereas lyophobic colloids, the viscosity of the dispersion medium is not greatly increased by the presence of lyophobic colloidal particles. Excuse me. Dispersions are stable. And coming to the lyophilic colloids, these lyophilic colloids dispersions are stable and generally in the presence of electrolytes. If you add some amount of electrolytic material to the hydrophilic colloids or lyophilic colloids, and the dispersions are stable enough, there is nothing will happen to the preparation. The stability of the preparation will not be affected by the presence of electrolytes in case of lyophilic colloids. But whereas lyophobic colloids, if you add any small concentrations of electrolytes, the lyophobic colloids the stability will be affected to a great extent. Means the lyophobic dispersions are unstable in the presence of even small quantity of electrolytes. And here lyophilic colloids, the dispersed phase consists of generally of large organic molecules such as gelatin, acacia and HPMC, methyl cellulose, all these will come under lyophilic colloids. and whereas dispersed phase ordinarily consists of inorganic particles such as gold or silver. Metallic oxides or metallic salts are there, those are all those will come under lyophobic colloids. This is a general description. Next, third classification of colloids is association colloids or amphiphilic colloids. Here these association colloids, as the name itself indicates, association means coming close to each other. Different number of molecules come close to each other, associate together, and they will form a sol like structure. The best example for this is surfactants. Surfactants will act as association colloids. We already come across the surface active agents or surfactants under interfacial phenomena in the physical pharmaceutics 1, right? So the surfactant molecules, they will act as association colloids. How they will act as association colloids? In the surfactants we come across one term, that is critical micellar concentration. What is critical micellar concentration? The term critical micellar concentration means the concentration where the surfactant molecules aggregate to form micellar structures. Means micelles will be formed. How the micellar structure will be formed? Here if you see, here you see, if you take, you all know how the micelles will be formed. If you take simply water in the beaker and if you add a small quantity of surfactant, the surfactant molecules will form a thin layer on the surface of the water, right? If you go on adding the surfactant molecules to water, the surfactant molecules will reach the bulk of the solution. At one particular point, what will happen? The surfactant, n number of surfactant molecules, they will aggregate to form a cluster like structure called micelles. These clusters, the cluster like structures of the surfactant molecules is given as micelles. Where at which concentration the micellar formation is going to takes place, that particular concentration is given as critical micellar concentration. At CMC, surfactant molecules will form micelles. So surfactant molecules, these micelles are forming. How the micelles are going to form? The surfactant molecules are associating together, they are forming a micellar structure. And this micellar structure, if you see the micellar structure, is it possible to visualize the micellar structure with the naked eye? No, it is not possible. And at the same time, is the micellar structure contains a single surfactant molecule? No. This micellar structure will contain around 20 to 100 or 20 to 150 number of surfactant molecules. And here this micellar structure contains more n number of surfactant molecules together, associating together, and they are forming a cluster like structure, that is micelles. So because of the formation of micelles, these surfactants will act as association colloids. Now whatever the surfactant molecules are forming the micelles, they will act as association colloids. Now at critical micellar concentration, the micelles are going to form association colloids. Now if the micelle is formed with the 50 or more number of monomers, that is micelles, the micellar structure contain minimum of 50 surfactant molecules, then the diameter of each micelle will be 50 angstrom units. 1 angstrom unit is equal to 10 power minus 8 centimeters. That is 10 power, sorry, Yeah. 1 angstrom unit is equal to 10 power minus 8 centimeters or 10 power minus 10 meters. Means this 1 angstrom unit is very less than less particle size, that is 1 nanometer is 10 power minus 9 meters. 1 nanometer is equal to 10 power minus 9 meters. 1 Yeah, 1 nanometer means 10 power minus 9 meters. 1 angstrom means 10 power minus 10 meters. Means angstrom unit is very less when compared to the nanometers. Means the micellar structure is 50 angstroms. Angstrom units means the particle size range is angstrom units. Means it is not lying under the nanometer size range also. So due to that reason, these micellars are designated as colloidal particles, or these micellars will lie under subcolloidal particles. Subcolloidal means less than the colloidal size range. Okay. Now the micellar structure size is 50 angstroms, which is less than the nanometer size range. So these are called as subcolloidal particles. Though they are having very fine particle size and they are not following the molecular dispersion characteristics, and due to that reason the association colloid means surfactants critical micellars under the micellars of surfactant molecules will lie under colloidal particles. So how the colloidal particle is formed by the surfactants, association of the surfactant molecules together to form a micellar structure. The micellar structure is having the particle size range of 50 angstroms nearly, and it is not having the properties of molecular dispersion properties. Due to that reason, this solutions of surfactant molecules is given as association colloids. These are the structure of micellars that can be formed by different types of surfactants in different types of media. Here you see this is the micellar. The micellar can be formed, means hydrophilic head is outside and lipophilic tail is inside. So the micellar structure is formed in the hydrophilic media, that is water. This is the micellar that is formed due to the when the external medium is non-aqueous, means that is oil, and internal medium is water, that is hydrophilic heads are inside, lipophilic tails are outside. And these are the lamellar micellars. Laminar micellars means the micellar structure is not a spherical one, it will form a laminar like structure. And these are this association colloid can be classified as, there are different types of association colloids. Say for example surfactants only, right? The surfactants are different types. What are they? Anionic surfactants, cationic surfactants, non-ionic surfactants are there, ampholytic or zwitterionic surfactants are there. Depending upon the charge that is present on the amphiphile, these are classified. Okay. Here whatever the opposite ions that are binding to the surface of the charged micellars is given as counter ions or giginions, and they will reduce the overall charge on the micellar structure. Here the viscosity of the system will increase as the concentration of the amphiphile increases, because micellars increase in the number and become asymmetric in aqueous solutions, and the CMC critical micellar concentration reduced by the addition of electrolytes, and salting out may occur at higher salt concentrations. And coming to the excuse me, preparation of lyophilic colloids, preparation of colloidal particles. How can we prepare the colloidal particles? Here the preparation of lyophilic colloids will be different methods, and preparation of lyophobic colloids will be different. Here when coming to the lyophilic colloids, it is very simple to prepare lyophilic colloids. Why? Because you just take the solvent whatever you want, either alcohol or water or any organic solvent, just dissolve the lyophilic colloidal material in the solvent by just simple dispersion or simple dissolving the, by dissolving the lyophilic colloidal material in the solvent material, you can get simple lyophilic colloidal system. But whereas preparation of lyophobic colloids, it is in the starting description itself we already studied that the preparation of lyophobic colloids is little bit difficult and tedious in nature. And here lyophilic colloids, and these lyophilic colloids are solvent living, they just simply they can, you just disperse the particles in the hydrophilic media. That is, if you want to prepare a hydrophilic colloids, means if you want to take water and just take the water, take the required quantity of any material, that is lyophilic material, that is acacia or gelatin or any type of lyophilic hydrophilic polymers, dissolve them in the water. Just by dispersing them in the water you can prepare hydrophilic colloids. If you want to prepare a lipophilic colloid, just take the organic solvents, take the lipophilic material, just dissolve them in the organic solvent, you will get lipophilic colloids. Whether it is the hydrophilic or lipophilic, whatever it may be, the solvent you are going to take will differ, but here that on whole you can tell that by simple dispersion of the material in the solvent material you can get a lyophilic colloid. And next coming to lyophobic colloids. Here the lyophobic colloids are generally prepared by two different techniques, those are dispersion methods and condensation methods. Dispersion methods include milling and grinding process, peptization, electric arc method, ultrasonic treatment method, addition of non-solvent and chemical methods, in condensation method addition of non-solvent and chemical methods will going to included. With this in the next session we will continue the preparation of lyophobic colloids and properties of colloidal particles, and remaining topics we will discuss in the next session. Thank you.